roots. Here we go. So we talked about I, the square root. So this is 7-8, and this is all about complex numbers. Complex numbers. Woo! And negative x, negative. So the square root of -1 is defined as I, okay? And that's called the imaginary unit, okay? And most square roots, whoops, I can pull down my screen. Most square roots can be expressed, or negative square roots can be expressed as in terms of I. So if you have like this, negative square root of 5, you can rewrite this as a square root of positive 5 times the square root of -1, right? Using properties of square roots, if I multiply them together, I get this. What's the square root of -1? What's the square root of -1? I, so I could rewrite this as square root of 5 times I, like that. Okay? Questions? Easy? Okay? Who can tell me how I could write negative square root of 36? Who can tell me how I could rewrite negative square root of 36? Go ahead, Cole.
You could take out the square root of 36 and the -1.
Square root of 36 times square root of -1. What is the square root of 36?
6.
So I could rewrite this as 6, what? 6i, just like that. Okay? How about negative square root of -9? 3 what? 3? No. Because first you do what's inside the square root. So it's square root, negative square root of 9 times -1, which is equal to negative, what's the square root of 9? 3i. So it's a negative 3i. So you can't have a negative 3i, and so on. Easy enough? Easy enough. So, complex numbers, moving on. Questions? You got that, Charlie? Good. Okay. So, complex numbers are numbers of the form. So all numbers in our number system are called complex numbers. But complex numbers in general can be expressed as a plus bi. Okay? Where this is the real part, this is the real part, and this is the imaginary part. So a lot of times we'll have a complex number that looks like this. 3 plus 2i, or 2 minus 7i, or something like that. If this number is 0, then it's a pure, called a pure complex number. And if this number is 0, it's called a pure, if this number is 0, then it's a pure imaginary number. If this part over here is 0, then it's a real number. So, for example, complex numbers can be broken into two things. They can be broken into imaginary numbers, imaginary, and then they can be broken into real numbers, okay? And so this is where A is equal to 0. So real numbers can be rational numbers, like rational numbers like -7, fractions, 2/5, decimals that can be expressed exactly, and irrational numbers. Is irrational? Yeah, 2 R's. Irrational numbers. Okay? Where you have like, what's an irrational number? Who can tell me an irrational number? Adam.
Isn't pi irrational?
Pi is irrational. So is anything that can't be taken out of a square root, like square root of 3. So is anything that cannot be expressed as a repeating decimal. Oh, I didn't put any there. But pi, there's another number, e, which is irrational. E is a rational number. Any square roots that can't come out of the box. E is another irrational. Imaginary numbers, you have complex imaginaries, which are ones like 3 minus 2i and 4 plus 6i and stuff like that. And then you have something called pure imaginary. Pure imaginary, which are like 2i, negative 3i, I, 15 over 7i. Those are pure imaginary because they just have the imaginary part. And this has a real part and an imaginary part. So complex are this form, pure imaginary are these forms. Both of these types are imaginary. All of these types, all the numbers are real numbers. Okay? Questions about that? Need more time to write stuff down? We're good? Now we get to do some math, now that you know all the definitions. Okay? So, you ready, Andres?
Yes.
Okay. Okay. So, adding and subtracting. Add and subtracting complex numbers. Okay. All you do is add and subtract the real part and the imaginary part. So for example, say I have 2 plus 3i plus negative 3 minus 2i. It's just like combining like terms. So you take the real part, you put it together. What's 2 plus negative 3? Negative 1. And what's 3i plus negative 2i? I, just plain I. Okay? So that's the way that one works. That's, did I do that right? I think I did that right. I did that right. Okay. Plus 3i, oh. All right. Let's try this one. 5 plus 2i minus 4 minus 3i. You try without a whiteboard. Just give that one a quick shot. Whoops. Whoops. There. Whoops. There. That's what okay. So, yeah, so you can either go 5 minus 4, which gives you 1, and 2 minus 3, right? So that becomes 2 plus 3, which makes 5i. Or you can rewrite this as a plus problem, so you could say it's plus negative 4 plus 3i. However you choose to do it, it works, all right? So it's just like combining like terms when you're adding complex numbers. Let's see. Multiplying complex numbers is a little more complex. A little more complex. So, so multiplying complex numbers, multiplying complex numbers. Okay. So if I have if I know that I is equal to the square root of negative 1, what do you think that I squared is equal to? What do you think I squared is equal to? Yes? I squared is a real number, but I is an imaginary. Okay? So that's really, we're not going to go into I cubed here and I to the fourth power, I to the fifth power, because they have that. I think that you'll see more in algebra 2 and stuff. But just so long as you know that I is -1 and I squared is, I is the square root of -1, and I squared is -1. So if I have something like this, 7i times 3i, all you do is you multiply together the real part, and then you multiply together the imaginary part. So you get 7 times 3, which is 21, times 20, I wrote 27, I meant 21, okay? 21, and times I squared. And what's I squared? -1, so you have 21 times -1, which gives you -21. All right? So that's how you multiply like something that has i's in it. But you have to be really careful, okay? Because say I have like something that looks like this. Square root of -4 times the square root of -9. Okay? Who thinks they know the answer to that? Intuitively, what would you guess? What would you do? What would you do if you're just multiplying these things? What's -4 times -9? That's 36, right? And so you would get the square root of 36. What's the square root of 36? 6, right? But this is wrong, okay? You have to be really careful with this. What you have to do is change this to a number in terms of I. So what's -4 in terms of I? Negative square root of 4 in terms of I. What's the square root of 4? 2 times the square root of -1 is? Let's just do it over, okay? So I have square root of -4, which can be rewritten as square root of 4 times the square root of -1, which is equal to what? Equals what? 2i, okay? Times the square root of -9, right? Which can be written as the square root of +9 times the square root of -1, which is equal to 3i. Okay? And now I'm going to multiply these two things together. When I multiply these two things together, I get 2 times 3, which is 6, and I times I, which is I squared. But what's I squared? -1, so you get 6 times -1, which is -6, not +6. So this one is the correct way, okay? So when you have negatives inside the square root like that, you can't just multiply them together and then take the square root of them. If there's negatives inside the square root, you got to pull it out in terms of I and then multiply it. Otherwise, you're going to get the wrong answer like I did over here. Yes? Don't ask me why it is.
Okay,
It's just the way the math works, okay? The way they define I and I squared and stuff like that. I know it doesn't make sense because you're kind of violating the rules of multiplying radicals. But with imaginary numbers, the rules kind of change, okay? So that's kind of how it works. All right? So, so that's a word of caution. Oh, there's a lot here. Sorry there's so much, but, right. Okay. So, do you need a break yet? Okay. You have a 30-second break. We're going to pause for station identification. Talk for 14 minutes. You don't need a brain break yet. All right. So if I have something like this, 7i times, this is where you use distributive property, minus 3. You just do it like we've been doing, like you did on your test. You multiply this times this, and this times this. So you get 14i squared, right? Minus 21i. What's 14i squared equal to in real numbers? negative 14, right? This is 14 times negative 1 minus 21i. So you just leave this as the complex number, negative 14 minus 21i. Okay? You can FOIL complex numbers, like just like you FOIL things with x pluses and minuses in them. Okay? So if you have binomials, 4 plus 5i, I multiply my two first terms. What do my two first terms give you? For 8. Okay? My two outer terms, which a lot of you guys seem to forget when you're multiplying binomials, 2 times 5i makes how many i's? 10i, right? What's 3i times 4? That's inner. What's that? 3i times 4? Negative 12i. Negative 12i. And negative 3i times positive 5a makes positive 15, or not positive, makes negative 15 I squared. And then you have to simplify, okay? You have an 8, you have a 10i and a minus 12i. Those are considered like terms. So you add those together, and you get negative 2i. And minus 15 times negative 1. So this term and this term always turn into real numbers. What's negative 15 times negative 1? Positive 15. So you take 8 plus 15 minus 2i, which is equal to 23 minus 2i. I think it's time for a you try. You ready to you try? Okay, try this one. I know you don't have whiteboards, but that's okay. Try this one. Negative 2 plus 3i times 5 minus 2i. Okay? See what? So multiply and simplify. Ready? So you multiply this times this, right, which gives you negative 4. This times this gives you plus 15i. Whoops, I went inner first. Outer gives you plus 10i, right? And the last gives you minus 6i squared. Okay? And then those two make 19i. And this is negative 4. And this becomes negative 6 times negative 1, which is positive 6. So you get negative 6, or positive 6 plus negative, did I do that right? I did that wrong. What did I do wrong?
Negative 2 times 5 is 10 is the first term.
Negative 2 times, I knew that. Negative 2 times, so what, negative 2 times 5 is 10. So you get negative 10 plus positive 6, which makes negative 4, right? Plus 19i, which is what I got when I did it on my paper. It's harder to talk and do it at the same time. Okay. Sorry, but we're not done. We got to talk about conjugates. So complex conjugates are really nice. Whoops. I want an eraser. I want my. What did I think of? Complex conjugates, they do something really cool, okay? Just like they make square roots go away, they make i's go away, okay? So for instance, say I have 3 plus 2i, its complex conjugate is 3 minus 2i. You just put a minus in, it's just like with square roots, okay? And then you FOIL that, right? So you get 3 times 3, which makes 9, okay? This times this, and this times this, which cancel each other out. 1 is minus 6i. I wrote 2. Yeah. One is minus 6i, and one is plus 6i, and then this times this makes minus 4i squared, okay? And so 9, so what is this, what's negative 4i squared equal to? Positive 4. So you get 9 plus 4, which makes 13, right? And these two things go away, and you're just left with plain old 13, okay? You could also do complex conjugates with pure imaginary numbers. So if I have one that is like negative 2i, what would be the complex conjugate of negative 2i? Positive 2i. Okay, so if I take negative 2i and multiply it by positive 2i, you get negative 4i squared, which is equal to what? 4. Okay, so that's the way that complex conjugates work. Okay, here you guys. Well, the place we use them, I'm going to give it you a try after I do this. Okay, we use them conjugates. I know I'm going fast, but I want to get conjugates are used for dividing complex numbers. Okay? For example, say I have 2 over 6 minus 3i. Okay? And I say divide this into this. Well, you don't really divide. You multiply by the complex conjugate. Ian, put your toy away. Okay? What would I multiply by, Ian? Get rid of that 6 minus 3i on the bottom. What's the conjugate of 6 minus 3i? Quinn. Yeah, but very good. So, but if I multiply by 6 plus 3i on the bottom, I also have to multiply it by on the top. Okay? 6 plus 3i. Why isn't that coming green? I clicked on the green one. Green. Green. I want green. Is it green now? There we go. Okay? So when I do that, this times this, on the bottom I get 36. The middle two terms cancel out, so I'm not even going to worry about that. And I get minus 9i squared, okay, which on the bottom becomes what? What's the bottom become? 36 plus 9, which is what? 45, okay? And then I distribute this. I have to multiply both terms. So I get 12 plus 6i, okay? And the last thing is they don't like you to leave it like this because this is really not in a plus bi form. So what you do is you break apart the two pieces into 12 over 45 plus 6i over 45. And then most likely you should reduce this, okay? I think 3 goes into here 4 times. And 3 goes in here 15 times. And then 3 goes in here 2 times. And 3 goes in here 15 times. And this is how you leave your final answer, like this. 4/15 plus 2i. Okay? And even though it says divide the complex numbers, you're really multiplying by the conjugate. That's what you're doing. Because having an I in the denominator it's not really good. You don't want to have that. Okay? You want to try one? Yes, you do. Okay. So here we go. There we go, Matt. Ooh, let's try this one. Q try. What's that's hard. Okay. Here we go. Q U try. 3i divided by negative 2 plus I. Okay? Just so you know, so you don't start off on the wrong foot, what would be the conjugate of negative 2 plus I? you don't change it to negative 2, you just leave the negative 2, you change this to negative 2 minus I, and so you have to multiply that on the top and the bottom. So go ahead, you try and then simplify. Let me show you if you didn't get this. So this times this, right? You don't even have, so that's 4, right? And this times this gives you negative I squared. Usually you have to worry about the middle part, but when you're multiplying in conjugates, the middle part disappears, right? So I'm not even going to put that there. Just understand that there is a minus 2i and a plus 2i that are being multiplied together, but they cancel each other out. This times this gives you minus 6i, right? And this times this gives you minus 3i squared, okay? When I simplify this, what's I squared? What's I squared? It's negative 1, so on the bottom you get 5. On the top, you get negative 6i minus 3 times negative 1, which is plus 3, okay? And if I were going to write this in the nice complex form, you want to put the real part first. This is the real part. This is the imaginary part. So you rewrite this as 3/5 minus 6/5 I. That's the best way to write that like that. Okay? Very good. Who else got that? Some of you got it? A few of you. Good. Yeah, so those are tricky. You want to try another one, or you want me to just shut up and do your math? Let's do one more, okay? Try this one. I know you. Try this. No yawning. 4 plus 3i squared, okay? Give that one a shot. You try. Very good, okay? So you should have gotten 7 plus 24i. How did he get that? He multiplied, so he FOILed, right? So a lot of you guys, like on your last quiz, okay, am I recording? I'm recording, okay? On your last test, you forgot that there's a middle term. You always do that. It's not 16 plus 9, so you get this times this, which is 16. The two outer terms gives you plus 12i, plus 12i, plus the two inner terms gives you plus 12i, and the two last terms gives you 9i squared. This is negative 9, right? This is 16, and you have plus 24i. So you have 16 minus 9, which is equal to 7, plus 24i. And you just leave it like that. Okay? Not too bad, right? Not too horrible. Okay? I like i's. They're fun.